In the winter of 1959, a group of Western journalists stood in stunned silence inside a Soviet laboratory. What they witnessed that day would haunt them for the rest of their lives. On a surgical table before them lay a large dog, its chest rising and falling with steady breaths. But attached to its neck was something that defied all logic, something that seemed ripped from the pages of a horror novel. A second head, a smaller dog's head, complete with its own shoulders and front legs, grafted onto the body of the larger animal. Both heads were alive, both were conscious, both were breathing. And when the scientist in the white coat offered a bowl of milk to the smaller head, it lapped eagerly, the liquid dribbling from its severed esophagus onto the fur of its unwilling host. This was not science fiction. This was not a carnival trick. This was the work of Dr. Vladimir Demikhov, a Soviet surgeon who would become known as both a pioneer and a monster, a genius and a madman. His experiments would shock the world, spark international outrage, and yet, paradoxically, lay the groundwork for some of the most important medical breakthroughs in human history. This is the story of a man who dared to play the role of creator, who stitched together living creatures in ways nature never intended, all in the pursuit of knowledge. It is a story of ambition, of Cold War rivalry, of ethical boundaries pushed to their absolute limits. And at its center are the dogs, the silent victims, and unwitting pioneers whose suffering would eventually save countless human lives. Before we dive deeper into this extraordinary and disturbing tale, I want to ask you something. If you find this story as fascinating as I do, take a moment right now to hit that like button and subscribe to this channel. Your support helps us bring more incredible historical stories like this one to life. And please drop a comment below. I'd love to know your thoughts on the ethics of scientific experimentation. Where should we draw the line between progress and morality? Now let us travel back in time to understand the man behind these experiments and the world that shaped him. Vladimir Petrovich Demikhov was born on July 18, 1916, in the small village of Kuliny, in what is now the Volgograd Oblast of Russia. He came into the world during one of the most turbulent periods in Russian history. The First World War was raging, and within a year the Russian Revolution would overturn centuries of Tsarist rule and usher in the Soviet era. Young Vladimir grew up in a world of chaos and transformation, where old certainties were being swept away and new possibilities seemed limitless. From an early age, Demikhov displayed an unusual curiosity about the workings of living things. While other children played in the fields, he was known to dissect small animals, studying their organs with intense fascination. This was not the behavior of a cruel child, but rather of one possessed by an overwhelming desire to understand the machinery of life itself. His parents, simple farming folk, did not quite know what to make of their unusual son. As he grew older, Demikhov's interests crystallized around biology and medicine. He was particularly fascinated by the heart, that mysterious pump that kept all living creatures alive. In his teenage years, he would spend hours drawing diagrams of the circulatory system, wondering if it might one day be possible to replace a damaged heart with a healthy one. This was in the 1930s, mind you, when such ideas were considered pure fantasy, the stuff of science fiction writers, not serious scientists. Demikhov pursued his education with relentless determination. He enrolled at Moscow State University, where he studied physiology. It was here that his revolutionary ideas began to take concrete form. In 1937, at the age of just 21, while still an undergraduate student, Demikhov achieved something remarkable. He designed and built the first artificial heart device and successfully implanted it into a dog. The animal survived for several hours, with the mechanical pump keeping its blood flowing. This was unprecedented. No one had ever done anything like this before. Think about that for a moment. A 21-year-old student working with primitive equipment in a Soviet university laboratory managed to create a mechanical heart. This was decades before the first human heart transplant, decades before bypass machines became standard in operating rooms. Demikhov was not just ahead of his time, he was operating in a completely different temporal dimension than his peers. But history, as it often does, interrupted the trajectory of scientific progress. In 1941, Nazi Germany invaded the Soviet Union, launching Operation Barbarossa, one of the largest and most devastating military campaigns in human history. Demikhov, like millions of other young Soviet men, was called to serve his country. He spent the war years as a pathologist in the Red Army, examining the bodies of fallen soldiers, learning intimately the ways in which the human body could be damaged and destroyed. The war years were formative for Demikhov in ways that went beyond his medical training. He witnessed suffering on an unimaginable scale. He saw young men whose hearts had been torn apart by shrapnel, whose organs had been destroyed by explosions, who lay expiring on operating tables because there was simply no way to replace what had been damaged. These experiences hardened his resolve. He became convinced that if organs could be destroyed, they could also be replaced. If hearts could be stopped by bullets, they could also be transplanted from one body to another. When the war ended in 1945, Demikhov returned to his research with renewed intensity. The Soviet Union, despite its massive losses, emerged from the war as a superpower. The Cold War was beginning, and with it came a fierce competition between East and West in every domain, including science. The Soviet leadership understood that scientific achievements could be powerful propaganda tools, demonstrating the superiority of the communist system. They were willing to fund ambitious projects, to support scientists who promised breakthrough discoveries. Demikhov found himself in the right place at the right time. He joined the Moscow Institute of Surgery, where he was given laboratory space and resources to pursue his transplant research. His goal was audacious. He wanted to prove that organ transplantation was possible, that one day surgeons would be able to replace failing hearts, lungs, and livers with healthy organs from donors. But to achieve this, he would need to solve countless technical problems. How do you connect blood vessels from different bodies? How do you prevent the immune system from rejecting foreign tissue? How do you keep organs viable during the transplant process? Demikhov decided that the only way to answer these questions was through experimentation, and his experimental subjects would be dogs. Why dogs? They were readily available, their physiology was similar enough to humans to provide useful data, and frankly, in the Soviet Union of the 1940s and 1950s, there were few ethical constraints on animal experimentation. Dogs were seen as expendable resources in the pursuit of scientific knowledge. Between 1946 and 1950, Demikhov performed a series of increasingly complex surgeries. He transplanted hearts into dogs, connecting the donor heart alongside the recipient's original heart so that two hearts beat simultaneously in one chest. He transplanted lungs. He even transplanted hearts and lungs together as a single unit. Many of his experimental subjects did not survive the procedures, but some did, living for hours, days, or even weeks with transplanted organs. Each success, however brief, proved that what the medical establishment thought was impossible was actually achievable. In 1946, Demikhov performed the world's first successful heart-lung transplant in a dog. The animal survived for several hours. In 1948, he performed the first successful liver transplant. Then, in 1951, he achieved what many consider his most important scientific accomplishment. He performed the first successful coronary bypass surgery in a dog, redirecting blood flow around a blocked artery. This technique, refined over the years, would eventually save millions of human lives. Today, coronary bypass surgery is one of the most common cardiac procedures in the world, and it all traces back to Demikhov's work on those Soviet laboratory dogs. But Demikhov was not satisfied with these achievements. He had a vision that went beyond simply replacing individual organs. He wanted to understand whether an entire additional body could be supported by a single circulatory system. Could one set of organs support two complete animals? It was a question that seemed absurd, even grotesque. But for Demikhov, it was a logical extension of his research. If he could graft one complete organ system onto another body, he reasoned, he could learn invaluable lessons about blood vessel surgery, tissue rejection, and physiological compatibility. This line of thinking led him to conceive his most controversial experiment, the creation of a two-headed dog. The first attempt took place in 1954. Demikhov selected two dogs for the procedure. The first was a large German Shepherd, strong and healthy, which would serve as the host. The second was a smaller dog, a puppy really, whose head and upper body would be grafted onto the larger animal. The surgery was extraordinarily complex, requiring Demikhov to connect major blood vessels with microscopic precision. He attached the puppy's brachiocephalic artery to the host dog's jugular vein, allowing blood to flow into the grafted head. He carefully connected veins to allow blood to return to the host's circulatory system. When the surgery was complete and the anesthesia wore off, something remarkable happened. The grafted head began to move. Its eyes opened. It looked around the room with apparent awareness. When someone approached, its mouth opened and it tried to bark, though no sound came out because its windpipe was not connected to lungs. The host dog, meanwhile, seemed confused by the addition to its body, but otherwise behaved normally. Demikhov had created a living chimera, a creature with two heads, two brains, two sets of eyes, but sharing a single circulatory system. It was an achievement of surgical technique that bordered on the miraculous. But it was also deeply disturbing, raising immediate questions about the nature of consciousness, identity, and suffering. The first two-headed dog lived for only 4 days before complications set in, and the creature had to be put down. But Demikhov was undeterred. He had proven the concept was viable, and he set about refining his technique. Over the next several years, he would create approximately 20 more two-headed dogs, each one a refinement on the last. The procedures followed a similar pattern. Demikhov would select a large, healthy dog as the recipient. Then he would take a smaller dog, usually a puppy, and surgically remove everything below the lungs. The puppy's heart and lungs were removed, since these functions would be provided by the host. What remained was the head, neck, shoulders, and front legs, essentially the upper quarter of the animal. This section was then grafted onto the neck of the larger dog, with blood vessels carefully connected to allow the host's circulatory system to supply the grafted portion. When successful, both heads would be fully conscious and capable of independent movement. The grafted head could see, hear, and react to stimuli. It could eat and drink, though since its esophagus was severed, food and water would simply spill out onto the host's fur. The grafted head would often lick its lips, show apparent thirst or hunger, and react with what seemed like pleasure or displeasure to different stimuli. Meanwhile, the host dog would control the shared body, walking around the laboratory with its passenger head attached to its neck. The survival times varied significantly. Some of the composite creatures lived only a few days before tissue rejection or other complications proved fatal. Others survived for much longer. Demikhov's most successful case lived for 29 days, nearly a full month with two heads on one body. During that time, both heads displayed independent behaviors, sleeping at different times, reacting differently to stimuli, apparently maintaining separate consciousnesses. For several years, Demikhov conducted these experiments in relative obscurity. The Soviet scientific community knew of his work, but the broader world remained unaware. That changed in 1959 when the Soviet government decided to showcase Demikhov's achievements to the West. The decision was deeply rooted in Cold War politics. The space race was in full swing. The Soviets had launched Sputnik in 1957, shocking the world and demonstrating their technological prowess. They were constantly looking for new ways to prove the superiority of Soviet science over Western capitalism. Demikhov's two-headed dog seemed like perfect propaganda material. Here was a Soviet scientist achieving what Western doctors could only dream of, pushing the boundaries of what was medically possible. In 1959, the Soviet authorities invited Western journalists to witness Demikhov's work firsthand. Among those who accepted was a team from Life magazine, then one of the most influential publications in the United States. What they saw left them stunned. The journalists were led into Demikhov's laboratory at the Institute of Experimental Biology, where they were introduced to his latest creation, a large dog named Brodyaga, which means wanderer in Russian, stood before them with a smaller head grafted onto its neck. The smaller head belonged to a puppy named Shavka, whose name meant mutt. Both heads were alert and active. Demikhov demonstrated the creature's capabilities with clinical detachment. He offered milk to Shavka's head, and the grafted puppy lapped it up eagerly. The liquid dribbled out through the disconnected esophagus, but the head kept drinking, apparently experiencing thirst and the satisfaction of drinking. When Demikhov approached with a tool, both heads reacted, turning to look at him. When he touched Shavka's ear, only Shavka's head responded. When he touched Brodyaga, the larger dog's head reacted. They were two separate minds in one body. The journalists captured everything on film. Photographs showed the bizarre creature in stark black and white, images that seemed to come from a nightmare rather than a scientific laboratory. There was the two-headed dog drinking milk, walking around, lying down with both heads resting. The images were simultaneously fascinating and horrifying. When Life magazine published the story, the reaction was immediate and intense. The Western public was horrified. Letters flooded into the magazine's offices, with readers expressing outrage at the apparent cruelty of the experiments. Animal welfare organizations launched protests. Editorials appeared in newspapers calling Demikhov a monster, comparing him to Dr. Frankenstein from Mary Shelley's novel. Religious leaders condemned the work as an affront to God and nature. Scientists debated the ethics and value of such extreme experimentation. The photographs spread across the globe, appearing in newspapers and magazines worldwide. People who had never heard of Vladimir Demikhov suddenly knew his name, though not in the way the Soviet authorities had hoped. Instead of showcasing Soviet scientific superiority, the images had made Demikhov appear as a mad scientist, conducting cruel experiments on innocent animals. The reaction in the Soviet Union was more muted, but still mixed. Some hailed Demikhov as a pioneer, a bold scientist pushing the boundaries of knowledge. Others were uncomfortable with the attention his work was receiving and the negative international press. The Soviet government, which had orchestrated the publicity, began to have second thoughts about promoting such controversial research. But what was the actual scientific value of these disturbing experiments? This is where the story becomes more nuanced. While the two-headed dogs were sensational and grabbed headlines, they were actually byproducts of genuinely important research. Demikhov was not creating these chimeras for spectacle or out of sadistic curiosity. He was developing and refining surgical techniques that would prove crucial for organ transplantation. Through these experiments, Demikhov learned how to suture blood vessels of different sizes, how to minimize clotting during complex surgeries, how to manage the physiological challenges of connecting different circulatory systems. Every two-headed dog that survived, even for a few days, provided invaluable data about tissue compatibility, rejection responses, and surgical technique. Consider what Demikhov was working without. He had no immunosuppressive drugs like cyclosporin, which would later revolutionize organ transplantation by preventing rejection. He had no advanced imaging technology to plan his surgeries. He had no team of specialized technicians with modern equipment. He was working with basic surgical tools in a Soviet laboratory, yet achieving results that leading Western surgeons thought impossible. His techniques and findings were meticulously documented. In 1960, Demikhov published a groundbreaking textbook titled Experimental Transplantation of Vital Organs. The book detailed his surgical methods, his findings on tissue compatibility, his innovations in blood vessel surgery, and his vision for the future of organ transplantation. Despite the language barrier and Cold War tensions, the book found its way to Western medical libraries, where it was studied by surgeons who were themselves working on transplant surgery. One of those surgeons was Dr. Christian Barnard of South Africa. Barnard, who would later achieve world fame for performing the first successful human heart transplant in 1967, traveled to the Soviet Union specifically to meet Demikhov and observe his techniques. Barnard spent 3 months studying under the Soviet surgeon, learning the intricate methods of connecting blood vessels, understanding the physiological challenges of transplantation. Years later, Barnard would openly acknowledge his debt to Demikhov. In interviews and in his own writings, Barnard called Demikhov his teacher, crediting the Soviet surgeon with laying the groundwork for human organ transplantation. When Barnard transplanted a heart into Louis Washkansky in December 1967, making headlines around the world, he was building directly on the foundation Demikhov had established with his dog experiments in Soviet laboratories. This is the profound paradox at the heart of Demikhov's legacy. The same experiments that horrified the world, that led to condemnation and accusations of cruelty, also paved the way for medical advances that have saved countless human lives. The two-headed dogs, those disturbing chimeras that seem like monsters from a horror film, were stepping stones on the path to routine heart transplants, liver transplants, and other organ replacements that today save thousands of lives every year. But let us return to the experiments themselves and consider what the dogs actually experienced. This is a question that troubled many observers then and continues to trouble us now. Were the animals suffering? Were they aware of their bizarre condition? The evidence suggests that both heads maintained independent consciousness. The grafted head would show signs of hunger, thirst, and fatigue independent of the host. It would fall asleep at different times than the main head. It would react to stimuli with apparent pleasure or discomfort. When teased or threatened, it would try to bite. When petted, it would seem to relax. All of this suggests that the grafted head was experiencing sensations and emotions. The host dog, meanwhile, seemed largely indifferent to its passenger. After initial confusion, the larger dog would go about its business, walking, eating, and resting, with the additional head simply along for the ride. There is no evidence that the host dogs experienced significant distress from the grafted portions. But what about the grafted puppy? It was essentially a severed upper body, kept alive by someone else's circulatory system, unable to eat properly, unable to breathe on its own, attached to a foreign body. Did it suffer? Did it know something was terribly wrong? Demikhov insisted that the animals were not in pain. He claimed that his surgical techniques minimized suffering and that the dogs were well cared for. He pointed to their apparent normal behaviors, their reactions to stimuli, their seeming contentment at times, as evidence that they were not suffering. Critics were not convinced. They argued that the animals might be experiencing significant distress that was simply not being recognized or acknowledged. They pointed out that dogs cannot verbally report their suffering, and their stoic behavior might mask significant discomfort. The fact that the grafted heads would desperately drink water or milk, only to have it spill out uselessly, seemed to many a sign of ongoing distress. The ethical debates that surrounded Demikhov's work in the 1950s and 1960s anticipate many of the discussions we still have today about animal experimentation. How much suffering is acceptable in the pursuit of scientific knowledge? Do the potential benefits to humans justify the use of animals in painful or disturbing experiments? Where should we draw the line? There are no easy answers to these questions. Those who defend Demikhov's work point to the lives saved by organ transplantation, the millions of people who have received new hearts, livers, kidneys, and other organs because of techniques he pioneered. They argue that the suffering of a few dozen dogs was a necessary price for this medical revolution. Critics counter that the ends do not always justify the means, that there must be limits to what we do to other creatures, even in the name of progress. They question whether the specific experiments with two-headed dogs were truly necessary or whether they were more about spectacle and proof of concept than genuine scientific inquiry. The truth, as is often the case, probably lies somewhere in between. Demikhov's organ transplant work was undeniably groundbreaking and laid essential foundations for modern surgery. The two-headed dog experiments, while more sensational, did provide valuable data about blood vessel surgery and tissue compatibility. But the suffering caused to the animals is also undeniable and raises serious ethical concerns that should not be dismissed. Let us continue with Demikhov's story, for his life after the international sensation tells us much about the nature of scientific fame and the challenges faced by pioneers. After the initial burst of international attention, Demikhov continued his work, but the Soviet authorities became increasingly uncomfortable with the negative publicity. The two-headed dog experiments were quietly discontinued in the early 1960s. Demikhov shifted his focus to other aspects of transplant surgery, continuing to refine techniques and train new surgeons. But despite his groundbreaking achievements, Demikhov never received the recognition within the Soviet Union that his work deserved. The very controversy that had made him famous internationally made him a problematic figure domestically. He was never elected to the prestigious Soviet Academy of Sciences, an honor routinely bestowed on scientists of lesser achievement. He was not given the resources or the laboratory space that would have allowed him to continue pushing boundaries. Instead, he was largely sidelined, watching from afar as Western surgeons built on his foundational work and received international acclaim. When Christian Barnard performed the first human heart transplant in 1967, Demikhov was still working in relative obscurity in Moscow. While Barnard became a global celebrity, feted by world leaders and appearing on magazine covers, Demikhov remained unknown outside of specialized medical circles. It was a bitter irony for the man who had made the surgery possible. Barnard, to his credit, never forgot his debt to Demikhov. He continued to cite the Soviet surgeon's contributions, calling him one of the most important figures in the history of transplant surgery. In later years, Barnard would say that if there was a father of heart transplantation, it was Demikhov, not himself. Through the 1970s and 1980s, Demikhov continued his research, though with diminishing resources and recognition. He trained many Soviet surgeons in transplant techniques, passing on his knowledge to new generations. He wrote additional papers and books, documenting his methods and findings. Meanwhile, organ transplantation was becoming routine in the West. Hearts, livers, kidneys, and lungs were being successfully transplanted with increasing frequency. The development of immunosuppressive drugs solved many of the rejection problems that had plagued early attempts. Techniques that Demikhov had pioneered were refined and improved. Each successful transplant was, in a sense, a vindication of his work, though he rarely received credit. As the Soviet Union crumbled in the late 1980s and early 1990s, there was a renewed interest in Demikhov's work. Young Russian scientists and historians began to recognize the magnitude of his achievements. There were efforts to rehabilitate his reputation, to give him the honors he had long been denied. In 1998, Demikhov was finally awarded the Order of Merit for the Fatherland, one of the highest honors in the new Russian Federation. It was belated recognition, coming decades after his most important work, but it was recognition nonetheless. Vladimir Demikhov passed away on November 22, 1998, at the age of 82. He died quietly in Moscow, largely unknown to the general public despite having revolutionized medicine. His passing was noted in medical journals, where colleagues mourned the loss of a pioneer, but barely registered in the mainstream press. Today, Demikhov's legacy is complex and contested. In Russia, he is increasingly recognized as a national hero of science, a pioneer whose work put Russian medicine at the forefront of surgical innovation. There are efforts to preserve his memory, to establish museums and archives dedicated to his work. In the broader world of medicine, Demikhov is acknowledged as a foundational figure in organ transplantation. His textbook, Experimental Transplantation of Vital Organs, is considered a classic in the field. His techniques, refined over decades by other surgeons, continue to save lives every day. But the two-headed dogs remain controversial. The images from 1959 continue to circulate, disturbing new generations who see them online or in history books. They raise the same questions they raised 60 years ago. Was this necessary? Was this ethical? Was this the work of a genius or a madman? The story of Demikhov and his two-headed dogs also offers lessons about scientific progress and its costs. Throughout history, medical advances have often come at significant cost, sometimes borne by those who could not consent to the sacrifices being made on their behalf. Animals have long been used in research that ultimately benefits humans. Human subjects have sometimes been experimented upon without proper consent or ethical oversight. The path of medical progress is littered with moral compromises. Demikhov operated in a time and place where ethical constraints on animal experimentation were minimal. The Soviet system prioritized results over process, outcomes over methods. He had the freedom to push boundaries that Western scientists, constrained by emerging ethical frameworks, did not have. This freedom allowed him to make discoveries that others could not, but it also led to experiments that crossed lines many would consider unacceptable. Today, we benefit from the knowledge gained by those morally questionable experiments while simultaneously condemning the methods. This creates an uncomfortable cognitive dissonance. When someone receives a heart transplant that saves their life, they benefit directly from Demikhov's work, from the suffering of those Soviet dogs. How do we reconcile our gratitude for the medical advance with our horror at the experiments that made it possible? There are no easy answers. Some argue that we must judge historical figures by the standards of their time, not ours. By the standards of 1950s Soviet science, Demikhov's work was groundbreaking and his methods acceptable. Others argue that certain ethical lines are absolute, that cruelty is cruelty regardless of the era or the potential benefits. Perhaps the most important thing we can do is learn from Demikhov's story. His achievements show us what is possible when brilliant minds tackle seemingly impossible problems. His methods remind us why we need ethical frameworks to govern research. His two-headed dogs stand as both a testament to human ingenuity and a warning about the costs of unconstrained scientific ambition. If you have stayed with me through this entire story, I want to thank you for your attention and engagement with this difficult but important historical episode. Stories like this one challenge us to think deeply about science, ethics, and the price of progress. If you found this video thought-provoking, please do not forget to give it a like and share it with others who appreciate deep dives into fascinating historical events. Subscribing to the channel ensures you will not miss future videos exploring the most remarkable and sometimes disturbing moments in history. Now, let us consider what has happened in the field since Demikhov's time. Organ transplantation has become one of the great success stories of modern medicine. Every year, tens of thousands of organ transplants are performed worldwide. Hearts, livers, kidneys, lungs, pancreases, and intestines are routinely moved from one person to another. Face transplants, hand transplants, even uterus transplants have become possible. Each of these advances builds on the foundations laid by pioneers like Demikhov. The field has also grappled with the ethical issues that Demikhov's work raised. Today, animal experimentation is governed by strict ethical protocols. Research proposals must be reviewed by ethics committees. Alternatives to animal testing are actively sought. When animal experiments are necessary, researchers are required to minimize suffering and use the fewest animals possible. These ethical frameworks emerged partly in response to the kind of controversial experiments that Demikhov and others conducted. The horror that people felt when they saw the two-headed dogs helped drive the creation of animal welfare laws and research ethics boards. In a sense, those dogs did not suffer entirely in vain. Their suffering contributed not only to medical advances, but also to the ethical frameworks that now protect research animals. Interestingly, some scientists have revisited the concept that Demikhov explored with his two-headed dogs, though in very different contexts. Modern neuroscientists study split-brain patients and neural connectivity. Researchers working on head transplants, though the idea remains highly controversial, cite Demikhov's work as foundational. The concept of connecting separate neural systems continues to fascinate and challenge scientists. In 2015 and 2016, Italian neurosurgeon Sergio Canavero announced plans to perform the first human head transplant, essentially removing a patient's head and placing it on a donor body. Canavero specifically cited Demikhov's work as proof of concept, arguing that if a Soviet surgeon could keep two dog heads alive on one body in the 1950s, modern technology should make human head transplants possible. The announcement sparked intense debate within the medical community. Many surgeons called the idea fantastical and unethical. Others argued that it deserved serious consideration. While Canavero's plans have not come to fruition, the very fact that such discussions invoke Demikhov's name shows the continuing relevance of his work. The story of the two-headed dogs also offers insights into the nature of scientific discovery and fame. Demikhov did groundbreaking work but received little recognition, while those who built on his foundations became famous. This pattern repeats throughout the history of science. The pioneers who take the first difficult steps are often forgotten, while those who make the final, more publicly visible advances receive the glory. Consider the broader context of medical history. We remember Jonas Salk for the polio vaccine, but forget the countless researchers who made his work possible. We know Watson and Crick for discovering DNA's structure, but often overlook Rosalind Franklin's crucial contributions. Alexander Fleming is famous for discovering penicillin, but it was Howard Florey and Ernst Chain who actually developed it into a usable drug. Demikhov fits this pattern. Christian Barnard is remembered as the father of heart transplantation, his name synonymous with the procedure. Demikhov, who made Barnard's achievement possible, is known mainly to medical historians and specialists. It is a reminder that scientific progress is rarely the work of isolated geniuses, but rather the cumulative effort of many often unrecognized contributors. The Cold War context of Demikhov's work also deserves reflection. The competition between the Soviet Union and the United States drove tremendous scientific advances, but also created an environment where ethical considerations were sometimes sacrificed in the race for prestige. The space race led to both remarkable achievements and tragic losses. Nuclear research brought both nuclear power and nuclear weapons. Medical research saw both life-saving discoveries and questionable experiments. Demikhov's two-headed dogs were explicitly used as propaganda, a way for the Soviet Union to demonstrate its scientific prowess. This political dimension influenced how the experiments were conducted and publicized. The Soviet authorities wanted sensational results that would impress and intimidate the West. The welfare of the experimental animals was secondary to the political goals. This intersection of science and politics is not unique to the Cold War or the Soviet Union. Today, we see similar dynamics in areas like climate research, artificial intelligence development, and genetic engineering. Political and economic pressures continue to influence scientific priorities and methods. Demikhov's story reminds us to be vigilant about these influences and to ensure that scientific progress serves humanity rather than political agendas. As we near the end of our exploration of this remarkable story, let us return once more to those disturbing images that shocked the world in 1959. A large dog with a smaller head grafted to its neck, both heads alive and conscious, drinking, breathing, and looking around with apparent awareness. What do we see when we look at those photographs? Some see the horror of scientific overreach, of humans playing creator with living beings. Some see the tragic cost of progress, innocent animals suffering for human benefit. Some see the extraordinary capabilities of a brilliant surgeon who achieved what others thought impossible. Some see a cautionary tale about the need for ethical oversight in research. Some see a pivotal moment in medical history that ultimately saved countless lives. Perhaps we see all of these things, and that is what makes Demikhov's story so compelling and so troubling. It resists simple categorization. It challenges our assumptions about science, ethics, and progress. It forces us to grapple with uncomfortable questions that have no easy answers. Vladimir Demikhov was not a monster, though some of his experiments seem monstrous. He was not a simple hero, though his achievements were heroic. He was a complex man driven by a sincere desire to advance medical knowledge and save human lives, who worked in a system that gave him few constraints and little concern for the suffering his experiments caused. He was a product of his time and place, a Cold War scientist whose work reflected both the possibilities and the problems of that era. His two-headed dogs remain one of the most remarkable and disturbing episodes in the history of medical science. They represent both the heights of human ingenuity and the depths to which we can sink when ethical considerations are ignored. They remind us that progress often comes with costs, and that we must always ask whether those costs are justified. Today, as we continue to push the boundaries of medical science with gene editing, artificial organs, neural implants, and other technologies, Demikhov's story remains relevant. It reminds us to balance our drive for discovery with respect for life. It cautions us against letting ambition or political pressure override ethical concerns. It challenges us to ensure that our scientific advances truly serve the greater good. The world was indeed horrified when it saw Demikhov's two-headed dogs. That horror was appropriate, but perhaps even more important than the horror is what we do with that knowledge. If we learn from Demikhov's story, if we take both inspiration from his achievements and warning from his methods, then perhaps those dogs did not suffer entirely in vain. Thank you for joining me on this journey through one of the most fascinating and disturbing chapters in the history of science. I hope this story has given you much to think about regarding science, ethics, and the complex nature of progress. If you have thoughts or reactions, please share them in the comments below. I read every comment and value your perspectives on these important issues. Until next time, keep questioning, keep learning, and keep thinking critically about the world around us.